All right, here we are. I'm going to record an instructional video on, I guess, introduction to trigonometry. This is not a very, very well-encompassing intro. This is off the top of my head, but this is a really good start for, I guess, self-study. Anyway, I'm going to start, and now let's see where this goes. All right, so let me start. Okay, so trigonometry is really the basis of it is study of angles within a triangle, um, and the relationship between the sides within the triangle and the angle related, that relates them. So on a geometry basis, we typically start with a right triangle and we identify which angle we're going to study. So in this case, this is theta. If this is a 90, you can figure out what the other one is. It really is 90 minus theta if you need it, but in this case, I'm just going to focus on here. And it starts off with a definition of what definition of certain things, sine of this. This is a relationship between certain sides here, and it's literally you just have to memorize what they are. So the word sine, this is not pronounced sin, but sine. It's actually, I'm going to write this out here. Sine, it's called sine theta or sine of theta. Theta refers to a particular angle that the problem is specifically saying that again we're concentrating on this particular angle right here, and it's defined to be the side that's opposite. I'm going to abbreviate OPP divided by hypotenuse. And what these are, there are measurements. There are numbers. So if I'm standing over here, this is my opposite side, and this, of course, is my hypotenuse, just from definition of a right triangle. Um, on the other hand, the next, so this is one definition. Second definition is cosine. It's pronounced cosine, not cos. And it's, the full word of it is like sine, cosine. But anyway, it's written like abbreviated like this. And what that is, it's adjacent side. Adjacent means next to side. Adjacent divided by hypotenuse. And in this case, the adjacent side would be this one right here. If I'm standing in this corner, this would be my adjacent. And if I had a number for it, a physical, some number, let's say 7. I'm just making that up. 7. And the hypotenuse, let's just say, is 10. Well, whatever that is. So whatever the angle would create, this would be, the cosine would be 7 divided by 10, which is 0.7. And that's the value of cosine of that particular angle. Now, I didn't tell you what the degree measurement of theta is. In fact, you could find out if given some information. If given this information on a calculator, you can find out exactly what theta is in degrees or radians. But right now, I'm just going to be easy. So, but that's not what this lesson's about. It's just, I'm throwing this out there as I go along. Anyway, so there's a couple of, well, there's at least one more of the primary definitions. Sine is the first one, cosine second one, and the third one being tangent. It's abbreviated tan theta. It's pronounced tangent tangent theta or tangent of theta, whichever way you just say it. Sometimes we just say tan theta, but it's really not proper. And what the definition of what tangent is in terms of triangles, in terms of sides, it is opposite side divided by not hypotenuse, that would be a sine. This is divided by adjacent. So if I knew what my sides were, let's say if this is 7 and this is 4, well, it would be like, as an example, if this is adjacent to 7 and this is 4, well, that's the value of my tangent of that angle, of that particular angle. And I could convert this to decimals, and I could put this in a calculator and find out what theta is. But that, again, that's not what this is about. The second, and in a higher math, it's actually more important definition of what tangent is, and I'll just do it over here. It is sine value of that angle divided by cosine value. And the reason why it works out, if you just put opposite, the definition of sine, opposite divided by hypotenuse, and divide that by adjacent divided by hypotenuse, and I'm just going to do it right on the spot by, let me see, let's use, like literally say sine divided by, let's do, this in black. Sine divided by cosine, well, this divided by this, the word hypotenuse will cancel away, or the value of hypotenuse will cancel away, and you're going to end up with opposite side divided by adjacent side. That's the definition of using triangular definition, what tangent is. But again, in more advanced, beyond geometry, this is a very, very useful relationship. If I know what sine value is, sine some number, and I know cosine of, I could find out tangent, and of course I could find out what theta is with a calculator. All right, so that was really, really quick introduction to what sine, cosine, and tangents are. In a different video, I'll go into the reciprocal relationships. There's three more based on the sine, cosine, and tangent. There's three more, like one divided by sine, one divided by cosine, one divided by tangent. But I don't want to go into that right now. So what I actually wanted to do is tie this together with a little bit of, besides just the triangle, kind of take a pre-calculus approach using unit circle, and hopefully make some sense of that. So the idea of a unit circle, let's say, what is a unit circle? Unit means one. So if I have like, here is my origin, and I do in fact, I'll do a unit circle. Here is my unit circle. So here's, okay, so my original picture wasn't that great. All right, so let me grab that. Oh, nope, okay. All right, let me actually do this. Let me just quickly do this, and I'll just kind of like this. And there's my unit circle, perfect picture. And the idea is, like, if I lay out an angle, angles always start on your positive x-axis, and if I open up the angle, in fact, what I'll do is I'll erase this part only up to this point. Only, so I have, because it's a unit circle, the radius of this unit circle equals to 1, radius equals to 1, and as I, like, let's say like a bug or something is crawling up on this unit circle, and wherever it stops, let's just call that a point, some kind of point right there. Well, you could think of this as really forming forming an angle. This position of this point is forming an angle we're going to call theta first, like right there. That's the angle that opened up between the original x-axis and, wherever this stopped, this opened up. So I'm doing a bigger picture of that, but you could see it right here as well. And the idea here is really, I don't really have a triangle, although it's really not that far-fetched, it's not that far behind where you can actually see the triangle. But eventually we want to get away from the idea of having to see triangles all the time. We could just say, what is, sorry, I didn't mean that. I'm pressing. What is sine of some angle, let's just say 60 degrees, right? Without having to actually do a triangle that has a 60-degree angle built into it. So that's where I'm going with unit circle. So if this angle opens up to 60 degrees, what is sine of 60? And it turns out that there is a triangle built in here, that you could actually make a triangle wherever this point stopped. If you dropped a line straight, like a vertical to the nearest x-axis, then you do have a little triangle built inside, and you can actually see it right here. That's a triangle. Theta is the angle that we're focusing on. It's a right triangle because when you drop a height from wherever you are, like let's say from here, you drop in this is going to be a right angle. So you can build any triangle no matter where you stop on the unit circle, let's say you stop over here, therefore there's a right there, and all these triangles, and more importantly these angles right here, that's the angle that we're going to be focused on. We're going to call reference angle or reference triangle, but really it's not the triangle that we're concentrating on, it's the angle itself. Okay, so the word here is theta reference, kind of like this, and sometimes I'll just write theta r, which really means the same thing, reference. And the reason why we're using the word reference is we're going to refer back to it on a regular basis. Any angle can be referred through its reference angle. All right, I'm going to erase all this, and going to reuse that unit circle. So sorry. Oh, right there. Okay, so again, I'll start with a unit circle. Here's a unit circle. And what's nice about the unit circle approach, or in general, using XY axis as opposed to triangles, is we can visualize an angle that's greater than 90 degrees, or greater than, so as an example, if theta, if I want to know sine of, I don't know, 300 degrees, which is kind of like you can't really picture a triangle that has 300 degrees built inside of it. However, if we treat it like this, where the angle opens up from the original, from the x position, from the x-axis. Is there somebody outside? Why is Lola barking? Okay, from the original, and we're gonna open up the angle in a counterclockwise rotation. So we're gonna call this a positive rotation or positive spin, and this rotation is a negative spin. So by opening it by 300 degrees, we are really like, where are we going to end up? Where's the terminal or the ending side? So this is the starting position or starting side, and the ending side. Well, if you just imagine, 90 plus 90, it gets you. This will get you to 180. This will get you to 270, and so on. So where's 300 going to end up is basically, if we had a full spin around, as imagine like to here, this would be 300 degrees of rotation, but we only have this, so we are 60 degrees short of the full rotation. So it's kind of like this, and you can visualize, well, in that case, my angle is actually like this. This is 300 degrees. And I'm doing this in degrees and not radians as an introduction, but I'll very quickly I will switch to radians. But anyway, so here's a 300 degree spin in a positive direction, and I'm indicating by this indicator, the angle indicator, which way I'm spinning. I'm starting here and I'm going this. On the other hand, how else could I have gotten there? I could have, oh, it must be dogs or somebody walking outside. How else could I have gotten here? Well, I could have gotten here with starting here, but in a negative spin, negative direction by 60 degrees. So the reference angle, so theta r, because we end up at the same location, theta r will be the same for sine of 300 degrees or sine of negative 60 degrees. It's the same reference angle, and the reference angle will be, well, 60 degrees. By the way, reference angle is, when we say reference angle, it's always a positive value. It's never going to be like, well, it's a negative spin, it's negative 60, it's underneath the x-axis. No, reference angle is always, so this r is always, wait, I misspelled that, okay. I'm just, it's always positive. In other words, greater than 0. Okay. It could be 0. Sorry, in fact, I shouldn't say that. It could be 0. If the angle lands right here, let's say 180, what is the reference angle? Well, the reference angle, another way of thinking about it, is what's the angle that is made by the terminal side where you end up with the nearest x-axis. So in this case, in this 300, the terminal side ended right here, and the angle that's formed between the original, but between the nearest x-axis and the this terminal side is 60 degrees. However, if we land on a x-axis itself, like right here, we landed on it, this angle is 180, the actual theta is 180, but the reference angle is what? Well, it's 0 degrees. We landed on the x-axis. So the reference angle is the angle that the terminal side makes with the nearest x-axis. Be very clear, it's nearest x-axis, not the y. Don't care about the y. I shouldn't say I don't care about it, but that's not where we measure from. I mean, you could do a couple of practice problems. In fact, I think that's what I'll do now to reinforce this idea. So if I have, as an example, if I have theta equals, let's just put a couple of 210, another let's say negative, I don't know, like well, negative 210. How about negative 210? That's a different. So in fact, why don't I call them by different names so that it's not confused that I'm referring to theta all the time. So let's call it alpha, Greek letter alpha, and we'll call another one more beta. Let's say I don't know, 330. Yeah, well, you know what, a different one, because that's I say that they're going to be related. So 300, that same old 300 we just used. So how would I find what the reference angles are for these, for alpha, theta, alpha, beta? Uh, you can visualize it. Eventually, you could just kind of do it without a picture or without visualizing. It just kind of makes with experience. But basically, what you're saying is like, where is 210? Well, 210, where's it going to land? It's going to land, if this is 180, how much further do we have to go to reach 210? Well, 30 more degrees, because you could, 210 is 180 plus 30. So where's 30 going to land is approximately here. So this is right there. That is 30 degrees, and that is my actual reference angle. Notice how I'm referring to the nearest x-axis. So in this case, this reference angle is actually 30. Again, doesn't matter that it's below the x-axis or above the x-axis, it's 30. Okay. Now, how about the next one? So this one right here. Well, in this case, I'm going to do a negative spin. So I'm starting out in this direction. I mean this position. That's my starting position. But in this case, I'm going to spin in the negative direction. And again, this is 180 plus 30 more degrees. So I end up in a second quadrant. Notice second quadrant. But my reference angle is what? Well, what is this right here? If this is 210 or negative 210, I should say, negative 210, because I have a negative spin, this is 30 degrees, because it went negative 180 plus another 30 to reach negative 210. And notice that both of these, and just, like, not because every angle has a negative counterpart to it and the same, it's going to be the same reference angle. Not necessarily, depends where it lands. But in this case, I picked them on purpose to show you that completely two different angles, 210 and one negative 210, they land in different quadrants. The first one landed in quadrant 3, right, Q3, and this one landed in Q2, and yet they both have the reference angle, alpha reference, equals 30 degrees. And one more, last one, well, at least for the sample. What is my reference angle for beta? Beta reference. Well, you can visualize it. Eventually, you're just going to be able to spot it on you'll be able to answer that on the spot. But what is 300 degrees? You're like, all right, I'm going to spin. This would be 180. I'm sorry, this would be 360. But I don't have 360. I have only 300. So how much do I have to back up by? By 60 degrees. there's more than one way of doing it. I'm not going to talk about different ways, because for one it can be confusing, if I introduce too many ways at once. But that's the way I tend to think of this. Some people think of it in terms of 90 plus 90 plus another 90. Where are you at now? But I just know my basic, three 0, 0 degrees, but a full revolution is 360. So if I'm short by 60 degrees, so this is my beta reference will be 60 degrees. It's this one right here. I mean, it's this angle right here. Okay, and the actual angle is indicated by this long, kind of not long, but the circular spiral, but the reference angle is to the nearest x-axis, and in this case it's 60 degrees. So if this is 300, this would be 60 degrees. Okay, and you could practice on your own. If you can do a couple of problems. You literally just make up an angle. Um, you know, I don't know, 500 degrees, and figure out. Oh, let's do that. Let's go one beyond one revolution, right? Even though for the most part we're in more advanced math, we're really not concerned about more than one revolution, but it's not that far fetched. So here is example of my angle is 500 degrees, or even beyond that. But I don't know, like 7. Yeah, let's do another angle, alpha. Sorry, alpha. Let's say 750. In fact, negative 750, just for the sake of something different. So what's 500? Well, 500, I mean, you could start counting. 500 would be, this would be 360, and that's how we generate, we demonstrate that you start here, and then this is a revolution. Notice, right, it doesn't go to the same spot, because then it would be a spiral, and you don't know whether it was a negative spin or positive spin. When it's written like this, you could clearly see the starting out on the positive x-axis, or x-axis. Yeah, this is a positive spin. However, if I did this, kind of land at the same place, then you really can't tell whether it's a positive direction spin or negative direction spin, because it looks the same. Anyway, so what is 500? And 500 happens to be one of those, like, you just with enough practice, you just memorize certain key angles. So 500 would be the following. It's the first full revolution, 360, plus, well, this would be 540 to here, because you can add, if you want to add 180 to 360, this would be 540. But since I have 500, I am short by how many degrees? I am short by 40 degrees. So kind of like this. So I would indicate this by doing the following. So this is where it landed. So in other words, it's like a spin, a full spin, and keep going, and stop, and that is the angle 500. Um, and again, I happen to know that 540 will fall flat on the negative x-axis. So in this case, what's my reference angle is this one right here. Well, what is that? Well, that's what I'm short by from reaching 540, which is, in this case, it is reference angle equals 40 degrees. Whether it's whether you're short by 40 or you went over by 40, the reference angle will still be called 40, not positive, negative 40. Okay. Anyway, one last, I mean, this, by the way, in a real, if this was a class, this would take much longer, because I'd be stopping and doing more examples and interacting with students and so forth. But this is, you could stop and kind of think about this on your own. Anyway, so what is negative? So in this case, I'm going to spin negative. So I'm going to start kind of like going in this direction. And you could visualize there's a full spin, that's 360. I'm making really, really, unusually big. You typically don't do that, so let me do this. So here's 360. But I have to go to 720, which will be the second revolution, and beyond that by how much? Beyond 720. 720 would be 2 full revolutions, but beyond that I'll have another 30 degrees to reach that. So my actual angle is right there. That's what it starts here, and it rotates back in a negative direction, kind of like this. A full revolution, another revolution, plus a little bit more. And how much is a little bit more? Well, that's the reference. In this case, it is by 30 degrees. Okay. And I think I'll stop. I mean, as far as reference angles and so forth. Okay, so let me jump into like the like ultimately you just have to memorize certain key angles and certain values of trig ratios, of trig functions. So let's do this. So what are the important angles? And I'm going to create a table here. So the table starts with 0 degrees, 30 degrees, 45 degrees, 60, 90, and I typically put 180, even though it's a big jump here. Our reference angles will be from here to here. And you'll see the reference angle for 180 is the same thing as 0. Because both of them, like here is 0, the reference angle is 0. Here is 180. It falls onto the x-axis, so whatever this angle is, the actual reference angle is 0. But you'll see why I have specifically 180 listed out. I just have it. Okay. So anyway, so these are the reference angles or the reference triangles, in geometry. But right now, so eventually we're also going to do radians. So this is in degrees. Even though I did not really explain what radians are, but it's a type of measurement of angles in a more advanced math course like Precalc and Calc. Typically in Calc, all of calculus and above is done in radians. So and I'm not going to explain necessarily what a radian is right now, but it's the conversion of it between degrees and radians has to do with pi over 180 or 180 over pi and so on. So okay. So I'll just list them out. The radian measurements are, well, 0, 0. This is pi over 6. This is pi over 4. Pi over 3. Pi over 2. And lastly, this is pi. So half a circle, full, this revolution right there is 180, but it's also pi radians, because the radian, 2 pi is a full revolution, 2 pi radians. And I'm not going to go into the development why that is the case, but that just is the case. That almost by definition, in fact, it is by definition if you define what a radian is. Anyway, so here are our angles, and what you have to memorize eventually, it literally just it's a memorization thing, is trig values, or values of trig ratios of these particular angles. Are there other angles in between? Like, so I say 35. Of course there is. 30. There's infinitely many angles here, but these are the ones you're just responsible for knowing at the pretty much on the spot. Okay, and here is my sine of theta. So these are my thetas, right? Theta. So I'm creating a table here, and sine of theta. You just without developing it too much right now. Because that would be a lesson in itself, but you just have to memorize what the values are. And sometimes it actually makes sense to memorize them first, because then when you're actually developing them, you're like, oh, I see how that works, Anyway, sine of 0 degrees, because sine of 0 degrees is 0. Sine of 30 degrees, or sine of pi over 6, is 1/2. Notice 1/2, it's a flat number. There is no degree sign. There is no units whatsoever. It's a unitless measurement. It's just a pure number. So we got sine of 30 is 1/2. Sine of 45, which is pi over 4, it is this kind of weird number. Um, yeah, and I'm not going to get into how we develop it. It just is. Yeah. So next one is sine of 60 degrees is root 3 over 2. And lastly is 1, which really is square root of 4 divided by 2. So if you actually think about it, like, and I pointed out to when I teach this, there's like a pattern going on here, right? Like, in fact, I'll write the pattern, then I'll erase. The pattern will be like 0 over, or square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, and square root of 4 over 2. And if you were to simplify this, you're going to get this part, right? You're just going to get that. And you could actually, 0, square root of 0 is obviously 0, divided by 2 is still 0. So there we go. I'm going to erase this. Uh, Square root of 1 is 1. You don't need a square root. Divided by 1, and it's the same thing. It's just, it's a nice way to write out the pattern. This one, notice, it can be simplified. It is what it is. Square root of 2 divided by 2 is what it is. So, okay. Now this same, in fact, same thing here. You can't really simplify square root of 3 divided by 2, so it stays as is. But square root of 4 is simply a what? Square root of 4 is just 2, and I have 2 divided by 2, which is 1, and that's exactly what that is. So what you want to do is, the only reason I brought this up is like, hey, there's some kind of pattern here if you ever forget this, especially in the beginning. Eventually, nobody writes out what I just wrote, as far as the pattern. You just memorize these numbers, and you just know them cold. Okay. And lastly, notice 180. Well, 180 has this, pi has the same reference angle because as whether it's 0 or 180, they both fall flat on the x-axis. It's just with different quadrants or different locations. So since the reference angle is the same for both of them, it's the same. So in this case, it is, or you could think of, negative 0. There's no such thing as negative 0. It's just 0. Okay. So just have to memorize these reference angles and kind of make sense of the 180. Okay. Now let's continue with memorization of cosine. Cosine, instead of redeveloping, this, you just have to kind of like, once you have a sine values memorized, just have to recognize that the cosine is these numbers in reverse. Or another way of thinking about it, they are cross positions. So the 0 goes over here, this 1 goes over here, and so on as you move into the middle. So what I'll do is I'll just okay, let me undo that. Okay, so in fact, I'll just, so 0 goes over here, 1 goes over here, and this goes square root of 3 divided by 2. This one goes 1/2. Notice the only one of the reference angle does not really change its position. It's the middle one, because it changes position with itself, so it stays that way. But also makes sense because it's a 45-degree angle. So if here is a 45-degree angle, and if we go back and think about what I said earlier about the definition of sine cosine, sine and cosine refer to opposite and adjacent, but since they are the same in this case, it really doesn't matter which one, for a 45-degree angle, both, this one's 45, this one's 45. It's an isosceles, meaning the sides are the same, and you have a hypotenuse here. So whether it's opposite or adjacent divided by hypotenuse, it's going to be the same value, same number. That's why these two are exactly the same. Okay. All right, let me clear this out. And lastly, I will. So, I'm sorry. What about cosine of 180? Well, I don't want to get into it too much right now in one lesson, but you kind of like just kind of memorize, because this will have the same reference angle as Oh, I made a huge, major mistake without thinking about it. Cosine of 0 is not 0. It's cross, cross 1 came over here. Yeah, that's kind of silly. In fact, if you look at it this way, the sine increases from 0 to 1, right? And that these numbers are increasing. You may not recognize it, but they are. And cosine values decrease as theta goes from 0 to 90. They decrease in the same proportion, whatever you want, in the same steps, um, as this increases. All right, so lastly, what's 180? 180, well, the reference angle at 180 is 0, so it is going to be 1, but without having to explain it too much right now, which eventually I will, it's a negative 1, right? It's a negative 1 because it falls in a particular area of in the quadrants where cosine is negative. So I'm not going to get into that this second, but this is something you just memorize, if you will. Yeah, in fact, I think it's a very good idea to memorize it. And even if you don't memorize it, eventually you'll just memorize it by doing this a bunch of times. So lastly, what I want to do here, well, then I take it back. I'll do a couple of examples because this, you know, yeah, you could stop at any one time since this is a video. So lastly is tangent. How do I, tangent is defined to be sine divided by cosine. So I tell my students, you really don't memorize. I never memorize tangent values. Although I could, in my mind, I could picture them, but I really picture this table, and in my mind, what I say is, well, tangent is really sine values divided by cosine. So treat that as a ratio. So 0 divided by 1 is 0. And if you kind of jump around, like as an example, for 45, this, square root of 2 divided by 2 divided by itself will be just automatically 1. And of course, it makes sense for a tangent, since for a 45, the opposite side and the adjacent side are exactly the same for 45. Therefore, and whatever this is, doesn't matter what this is, they will be the same as each other. So anything divided by itself will be 1. Okay. So that's something you just, like, no, tangent of 45 is automatically 1. Now, tangent of the other ones are a little trickier, but this is important. This one is, so what is tangent of 90 degrees? Well, it's 1 divided by 0, but remember, you're not allowed to divide by 0. It's undefined, so literally we say the value of tangent of 90 is undefined. Okay, UND, undefined. And the other ones, you just kind of fit that in. So this is really square root of 3, because when you square root of 3 divided by 2 divided by 1/2, the 2's cancel. This one is the only one that's kind of a little bit of a pain to, you have to visualize 1/2 divided by this. It really is this, but for the most part, it's written, it can be left alone like this, but for the most part, it's written, using rationalization of denominator, it's written like this. Right? And I'm not going to get into that skill right now. So it's, either one of them in calc level. At the calc level, it's acceptable, either one. Uh, what you see in a textbook, it depends on the textbook. I've seen both. Okay. So this is strongly, like I'm emphasizing, you just want to know this very, very well, this table. So one of the things that troubles students as they go through calculus, as in trig, is really they keep forgetting this, or they keep, not, either they memorize it and then they lose it, but there's just no reason or excuse for not memorizing it, because once you memorize the first line, the second line is automatic, and the third line, as you need it, you just divide things out. Uh, like, I don't memorize the third line, except, well, I actually know this one, and know this one off the top of my head, and the other ones I just have to think. Oh, it's like, square root of 3 divided by 2 divided by 1/2. The 2's cancel. I come up with this in a couple of seconds. but the other ones, the 45 is, tangent of 45 is 1 automatically. Anyway, so let's do a couple of demonstration problems how this is useful without really going into like what's the word I'm looking for. I'm not going to go into unit circle approach because it becomes confusing if I do more than one skill at the same time. So let me do a next. Okay. So if I wanted to, I'll just do a bunch of, so sine. So it's really a process. It's a multi-step process, like 3 or 4 steps process, and you have to memorize certain things. And which approach you take, whether it's you take unit circle or what I'm about to show you, it's up to you. But ultimately, you just gotta be solid with finding sine, cosine, tangent of your basic angle, your or angles based on the reference angles. So as an example, let's do this. Let's do I don't know, sine of I don't know, two. Well, I said actually 210, right? 210. Earlier. Uh, let's do cosine of I don't know, negative. Yeah, negative 750 as before. Uh, and one more like a reasonable number. So like, what about sine of um, I don't know, negative negative 225? Okay, negative 225. Okay, so it's a multi-step process. The first step is let's establish well, a couple. Well, the first step is uh, which this angle, where does it fall? Where in which quadrant does it fall in, and what is its reference angle? So let's think about sine of 210. So it starts here, and you start to spin in this direction, positive direction. So how far does it go? Well, through experience, I basically say 210, this is 180 plus another 30. So there's my 210. This is my angle of 210. And what's important about it is the terminal side, but more importantly is actually what's the reference angle that forms right here with the x-axis. And just like before, but you could redo the problem mentally. Well, what is this angle? You want 180 plus another what? You want another 30. So your reference angle is really uh, so so theta reference is really 30 degrees. And we're going to refer to that 30 using that table what we just had on the previous page. I'm just going to put the values here. You can refer to that table, but I just know the values. So we're going to refer to this 30 degrees as if it's the original 210 with a little bit of a, well, important, but a little bit of a, an additional fact. So because it falls in a third quadrant, notice it's, Q3, that's where it falls. This is 1, right? Sorry. This is 1, and different ways of labeling. You could label it using Roman numerals, or you use Q3 like this, like quadrant 3. And this is quadrant 4, and then back up quadrant 1 if you rotate around. Anyway, so a couple of facts are important. It's important the fact that it fell in quadrant 3. It's important that the reference angle is this, and now let's put it together. Right? Well, before. So it really helps to remember this mnemonic device, right? Like, because at this point we are going to refer to 30, and we know what sine of 30 is. The sine of on the side here, I'll do sine of 30 degrees, because that's what I'm referring to, because it really is ultimately I could still make a little 30-degree triangle in here. Right here is 30 degrees. um, so the triangles are really not all, I mean, they're kind of lurking under the surface. I don't think of them as a triangle. I think of them as just simply 210. The angle spins here and leave it resulting in 30-degree reference. But the idea here is, well, I know what reference of sine of 30 degrees is 1/2. I know that for a fact from memory, but you can look back at the previous table. But now we're not sure about whether it's a positive value or negative value. And you just have to memorize this little device. Uh, all students take calculus. Or this A stands for all, S stands for sine, not cis, sine, tan, this is tan, and this is cosine. And the first letter of this, all students take calculus. Just kind of memorize that. And it's basically going to be a device to tell you whether the plus minus on my 1/2 is, whether it is plus or minus on that. And that really depends on where this 210 falls. So in this case, 210 fell in third quadrant. Well, in the third quadrant, only tangent is positive. By the way, right, I forgot to mention this. All students take C for calculus. It just tells you where that particular trig function is positive, and other functions are negative. So in the first quadrant, everybody's positive. In the second quadrant, sine is positive, but that means tangent is negative and cosine is negative if it falls in the second quadrant. In the third quadrant, tangent's positive, but sine and cosine are negative if the angle falls there. And in the fourth quadrant, cosine's positive, but that also means sine and tangent are negative if it falls there. So I'm going to erase this in a second, but just kind of note or write this down in your notebook as you're watching this. So this is a very helpful mnemonic device, and some teachers don't teach it this way, but I find it actually helps. It's in some ways it's better than unit circle approach. Although that unit circle also has its strengths as well. Um, so I'm going to erase this in a second, or at least, at least move it, right? I'm going to move it. So I'm going to move it all to the side, kind of like this. And notice what's happening. Like we land in the third quadrant. This landed in the third quadrant, right? But in the third quadrant, cosine, sorry, sine is negative because tangent is positive, but everybody else is negative. So my answer is really a combination of, well, what's the sine of reference angle, 30 degrees, which is 1/2, and then followed by either it's a positive or negative value depending which quadrant I'm in, and I am in the third quadrant, so therefore my answer is negative 1/2. So the answer there is a combination of a couple of facts, but it really is sine of 210 equals negative 1/2. That's my ultimate answer here. How I got there is a couple of steps, and if that was too fast, we'll do another couple of examples. But meanwhile, you can, obviously, you could, pause and rewind and go through the steps. Like it is a multi-step problem. Eventually, they become so quick that you don't think of them as multi-step. You just think of them as just one problem. Okay, so there's my answer. Let's do another, like a different angle here. I'm going to erase. Yeah, in fact, yeah, I'll erase because yeah, I'll erase. So you could pause, you could study this, but meanwhile, here's okay. So I'm going to leave the mnemonic device here, but the other come on. I'll leave this here. Next, so we'll do this one, right? So again, it helps, especially in the beginning, to kind of orient yourself. Where does this fall? In fact, if the angle is big, and I could either picture this in my mind where this falls. Yeah, I could picture exactly where it falls. But there's no harm or shame in like actually doing this picture. If this is a test, oh yeah, I'm not going to do this whole thing in my head. I'll do it on paper, just like so. Negative 750. So I'm going to spin in negative direction. So here is my negative 360, negative 720, and then I go how much further? Well, I have to go 30 degrees more. So what is my, so here's my negative 750. But really, what becomes important at this point are two things. This was my reference angle, and even though it doesn't look like it, but really the reference angle is 30 degrees, because you could say, 750 minus uh, 720, or is 30-degree difference, and it's 30 degrees. Okay, so I'll erase that. So my reference angle is 30 degrees. Now I'm taking a what of it? Well, I'm taking cosine. So what's cosine of 30 degrees? Well, from the table, or from hopefully memory soon enough, it is square root of 3 divided by 2. That's what this is. But the final answer will be a combination of that value with either a plus or minus in front of it. And that'll depend on which quadrant this angle fell in, and we're looking for, in this case, we're looking for cosine. So which quadrant what this angle fell in? Well, clearly fourth quadrant, right? Because that's why it helps to have a picture of it. It's in the fourth quadrant. And look at that. Cosine happens to be positive in the fourth quadrant. So if the angle falls in the fourth quadrant, and the question is asking about its cosine of that angle, the answer is going to be positive. Notice that the angle itself was a negative angle. I don't care about that. It could have been a positive angle as long as it got me to that location, to that fourth quadrant. And it doesn't matter how many revolutions or rotations it took me, as long as I landed in that quadrant, all cosines of all the angles in there will be positive. Now, in this case, with negative 750, I had to figure out what the reference angle is. It's 30. Cosine of 30 is this. So my final answer, overall answer, is really just positive square root of 3 divided by 2. Square root of 3 divided by 2. Now, I could put a plus in front of it to kind of for emphasis. It's a positive value. And lastly, let's because I definitely want to close this out video. It's getting late. Um, so let's do this sine over here. Well, I'm gonna do this. So very quickly, where does this fall? And I know these angles from years of using it. So this is a what? Well, this is 180. Oh, sorry, negative spin, right? Negative spin. So 180. And then how much further do I have to go past? Well, another 45 degrees. If you could just visualize 180, 225 minus 180 is another 45. So I have to go another 45, which gives me a reference angle. This right here is 45. That was convenient. And notice two things. Which quadrant we're falling in? This is in the second quadrant. And what's the function that we're trying to evaluate? Well, this is a sine. So who is positive in that quadrant? Well, it happens to be the sine is positive, right, in the second quadrant. So even though the angle was a negative value or negative angle, because it landed in such a quadrant, if I was looking for cosine there, my answer would be negative, or tangent would be negative. But because I'm looking for a sine in the second quadrant, well, I know the answer is going to be positive what? Well, the reference angle is 45. So what is sine of 45 degrees? Well, it is that square root of 2 divided by 2. So my final answer is positive square root of 2 divided by 2. So that's my answer here. I'll just write square root of 2 divided by 2 without the plus minus, plus sign, because just unnecessary. So there is my, multi-step, but it really flows after practicing, oh, I don't know, 10, 20,000 times. It flows pretty quickly. No, you don't have to practice, that much in order to become an expert on this. You're going to pick this up pretty quickly. Okay. All right, so kind of memorize this. All students take calculus. And this just tells you who's positive in which quadrant. Okay. All right, I think at this point I'll stop, and you could practice yourself. You literally just make up, well, you know what? Yeah, I guess you have to know which angles to make up. Something based on 30, 45, and so on. So I'll put up some kind of assignment. But meanwhile, as far as instructions, this is it. So okay, all right. And I will see you in class whenever. All right. Oh, sorry. What am I? I need to close this out. Okay. All right. Bye.